Hey guys, in this video we are looking at completing the square some more. So I wanted to show you why it's called complete the square, and then I decided while I'm doing that I might as well go through more examples for them as well, because it's a really important technique that we're going to be using a lot here at A level. So first up then, why is it called completing the square? It doesn't seem very linked to any squares at all. Every time we've done it so far, we haven't seen any squares, have we? Or have we? Maybe we have. We actually have. Okay, the easiest way to demonstrate it then is by example. So here we have x squared plus 12x plus 40. Now, x squared we can think of as a square with side lengths of x, like that. 12x we can think of as a rectangle with a side length of x and 12. And then 40, we can just think of 40 as some square with an area of 40, like that. So, what we then do is we cut this rectangle in half, like that. So we've now got two rectangles with a side length of x and a side length of 6, like that. Why do we do that? Good question. Well, now that we have those two rectangles, we can actually put one on the side of the square. So again, there's label stuff. The square has side length of x, so this rectangle has one side length of x and one of 6, and then the other rectangle we can put down here, like that. So again, this is 6 and this is x here. So what we're left with is almost a square. So if we fill this bit in, this is a square with side lengths of 6, like that. So the area of this square is 36. Now remember, we had a plus 40 on the outside. Now 36 of that 40 is now inside of this square. So we're now actually just left with a 4 on the outside. Again, because 36 of that 40 is now inside of this square. This is why it's called completing the square. So, if we now write this out algebraically, this square is x plus 6 squared, like that. And then we've got this plus 4 on the outside. So, this x plus 6 squared is actually a special type of quadratic. It's called a perfect square. Now, perfect squares have exactly one real root, or one solution. So, if we were to sketch x plus 6 squared, now, perfect squares hit the x-axis at one point and one point only. Let's find that point. Let's see why we do what we do. So, if we set y equals x plus 6 squared, and we want to find the x-intercept. Remember, the x-axis is the line y equals 0. So if we set y equal to 0, we get 0 is x plus 6 squared. If we then square root 0 equals x plus 6, and then finally we therefore minus 6 is equal to x. So this is why when we complete the square, the x-coordinate of the vertex is the opposite sign to the number in the bracket with the x. So if we were to plot that, it's going to look very roughly like this, where this point down here is minus 6, 0. So that would be our perfect square part plotted, but we've actually got x plus 6 squared plus 4. Now this plus 4 at the end translates our curve up by 4 places. So our actual quadratic is going to look something like this, where the coordinates of the minimum are minus 6, positive 4. So that's what's happening with the coordinates when we complete the square. Right, now we're going to go through some examples then. We're going to look at when a is equal to 1 and not equal to 1. Okay, first up then, we're going to have a look at an example where we're already in completed square form, and we want to, first of all, we're going to get the coordinates of the vertex, and then we're also going to solve the equation. So, let's see then, the coordinates of the vertex. Well, our y coordinate is always this number on the outside. So, we know then the coordinates are going to be some value for x minus 4 for the y coordinate. How do we get the x coordinate? Well, we set whatever is inside the brackets equal to 0. So, if we set 3x minus 1 equal to 0, we get 3x is equal to 1. Therefore, x is equal to 1/3. So the coordinates of the vertex, which here is going to be a minimum, if we expand the brackets out, we will get a positive x squared term, so it's a minimum. So the coordinates of the minimum are going to be 1/3 minus 4. Let's now have a look at solving this equation. So to solve it, we're first of all going to add the 4 to both sides. So we're going to have 3x minus 1 squared is equal to 4. We then need to square root. So we will get 3x minus 1 is equal to... Now this is the really important bit. This is the reason that most times we get 2 solutions. Remember, we get plus or minus the square root of 4. So plus or minus 2. If we then add the 1, 3x is equal to 1 plus or minus 2. And then dividing by 3, we get x is 1 plus or minus 2 all over 3. So we've then got 2 solutions. Let's call the first one x1. which I'm going to take to be 1 minus 2 over 3, which is going to give me minus 1/3, and then the other one, x2, is 1 plus 2 over 3, which is just 3 over 3, which is 1. Jobs again. Okay, next example. So, x squared plus 6x plus 8. So, what we're going to do with this guy, write him in completed square form, get the coordinates of the vertex, and then we are going to solve it from completed square form. Now, this would be an incredibly easy one to solve by factorising, but we're practicing completing the square. So, okay then. First of all, to write it in completed square form, we want a set of brackets with an x and a square on the outside. For now, we're going to leave the plus 8 at the end, and we're going to half 6, so the number attached to the x. Half of 6 is 3. Now, we're almost there. We just then need to square this number inside of the bracket, which would be 9, and take it away on the outside. So we're going to get minus 9 on the outside like that. So you always square that number and you always take it away without exception until we start playing with imaginary numbers. So that's a ways off. Okay, so we've got x plus 3 squared minus 1 as our completed square form. Now this is a happy quadratic, so it's going to be a minimum. So the coordinates of the minimum, well, we always get the opposite value of the number inside the bracket with the x. So we're going to get minus 3, and then the y coordinate is just that number on the outside. So our coordinates are minus 3, minus 1. Now let's have a look at solving. So if we set x plus 3 squared minus 1 equal to 0, we now want to solve this. So if we add the 1, we get x plus 3 squared is equal to 1 square root x plus 3 is plus or minus 1. Take away the 3, x equals minus 3 plus or minus 1. So our first solution, x1, let's go minus 3 minus 1, it's going to give us minus 4, or x2 is going to be minus 3 plus 1, which is going to give us minus 2, which, as I said, we could quite easily have got that by factorising, but we're going to be practicing completing the square. Okay, next up, so now we're looking at an example where a is not equal to 1. So this causes a bit of a problem for us, because to be able to complete the square, you need to have a single positive x squared term. However, in maths we like getting around problems like that. What we do is factor out, well here, we're going to factor out a 2 from the whole expression. So we're going to rewrite this as 2 lots of square brackets x squared minus 6x plus 9 over 2. Like that. So it's really, really important here. There are different ways of doing it. I think this is the most straightforward way. So I always try and present to you the simplest way to do stuff. So, very important, you take that factor of 2 out of every single term. So now we've done that, inside of the square brackets, we now have a quadratic with a single positive x squared. So we can complete the square in here now. So half of minus 6 is minus 3. So we got plus 9 halves on the outside, but we then need to take away 3 squared. Now 3 squared is 9, so we're minusing 9 on the outside, like that. So we've got 2 lots of x minus 3 squared. Now 9 halves minus 9. Now 9 wholes is 18 halves. So we've got 9 halves minus 18 halves, which is going to give us minus 9 halves. Okay, now we let that 2 back into the square brackets. It cannot get inside the round brackets. All it can do there is sit on the outside like that, but it will multiply minus 9 halves to give us a whole minus 9, like that. So the coordinates of our minimum here are going to be, well, positive 3 and minus 9, like that. Okay, so now we'll have a look at solving this bad boy. So we're now going to set 2 lots of x minus 3 squared minus 9 equal to 0. So add the 9, 2 lots of x minus 3 squared is equal to 9, divide by 2, x minus 3 squared is 9 over 2, square root x minus 3 is equal to plus or minus root 9 over 2. Add 3, x is equal to 3 plus or minus root 9 over 2. Now, if we don't have a calculator, we would need to sort out the sides. So we've got x is 3 plus or minus, right, root 9 over 2 is the same as root 9 over root 2. So we could say this is 3 over root 2. We would then want to rationalise the denominator. So we would get x equals 3 plus or minus 3 root 2 over 2. So our first solution, x1, is going to be 3 plus 3 root 2 over 2, and x2 is going to be 3 minus 3 root 2 over 2. You can leave them in third form unless you're asked for decimals, then just whack them in your calculator. Okay, final example for this video. So we got 3x squared minus 12x plus 14. So we're first of all going to write this in complete square form, and then we're going to try and solve it. Although we're going to run into a bit of a problem, which is gonna give us a nice little prelude to something coming later on. So, again we got a problem here. We've got 3x squared instead of a single x squared. So we need to factorise out 3. So we're going to have 3 lots of x squared minus 4x plus 14 thirds. Lovely. Right, now inside of the square brackets, we can complete the square. So we're going to get x minus 2 squared, like that, and we got plus 14 thirds, and then we have to minus 2 squared. 2 squared is 4, so we're subtracting 4, like that. Okay, so then we've got 3 lots of x minus 2 squared plus 14 thirds. Now what is 4 in terms of thirds? Every 1 whole is 3 thirds. We've got then 4 times 3 thirds, so we've got minus 12 thirds on the end, like that. So we've got 3 lots of x minus 2 squared, and 14 thirds minus 12 thirds is 2 thirds. Almost there, now we just gotta let that 3 back in. So again, it can't affect the things inside of the round brackets. It can only sit on the outside. Oops. Okay, so we got 3 lots of x minus 2 squared, and then 3 times 2 thirds is going to give us plus 2, like that. So, again we got a minimum here. So the coordinates of our minimum are positive 2 and positive 2. Now, let's think about this. We've got a happy quadratic, so the coordinates we've just found are of a minimum. Now the y value is positive, so that tells us this minimum is up above the x-axis. So what this means is our quadratic is always positive. It's never negative, and it's never 0. So, if we try and solve this, which we are going to do, we're going to run into a problem. So, we've got 3 lots of x minus 2 squared plus 2. Now, if we set this equal to 0 and try and solve it pretty quickly, we're going to run into a problem. Let's subtract 2. And we got 3 lots of x minus 2 squared equals minus 2. If we divide by 3, x minus 2 squared is equal to minus 2 over 3. No problems yet. If we square root x minus 2 is equal to positive or negative square root of minus 2 thirds. That's our problem. We cannot square root a negative number yet until we meet imaginary numbers. But we can't do it, yeah? I don't think you're going to see that until next year, or if you do further maths. So, this guy has no real solutions. So we can't actually solve this quadratic, which we're going to see more examples of when we come to something called the discriminant. of a quadratic. Okay guys, that's it for this video. Turned out to be a lot longer than I meant for it to be. I think next, I'm not going to do it in order of the book. I think next we're going to have a look at sketching quadratics. A very useful skill. Take care guys. Okay, final example for this video. So we got 3x squared minus 12x plus 14. So we're first of all going to write this in complete square form, and then we're going to try and solve it. Although we're going to run into a bit of a problem, which is going to give us a nice little prelude to something coming later on. So, again we got a problem here. We've got 3x squared instead of a single x squared. So we need to factorise out 3. So we're going to have 3 lots of x squared minus 4x plus 14 thirds. Lovely. Right, now inside of the square brackets, we can complete the square. So we're going to get x minus 2 squared, like that, and we got plus 14 thirds, and then we have to minus 2 squared. 2 squared is 4, so we're subtracting 4, like that. Okay, so then we've got 3 lots of x minus 2 squared plus 14 thirds. Now what is 4 in terms of thirds? Every 1 whole is 3 thirds. We've got then 4 times 3 thirds, so we've got minus 12 thirds on the end, like that. So we've got 3 lots of x minus 2 squared, and 14 thirds minus 12 thirds is 2 thirds. Almost there, now we just gotta let that 3 back in. So again, it can't affect the things inside of the round brackets. It can only sit on the outside. Oops. Okay, so we got 3 lots of x minus 2 squared, and then 3 times 2 thirds is going to give us plus 2, like that. So, again we got a minimum here. So the coordinates of our minimum are positive 2 and positive 2. Now, let's think about this. We've got a happy quadratic, so the coordinates we've just found are of a minimum. Now the y value is positive, so that tells us this minimum is up above the x-axis. So what this means is our quadratic is always positive. It's never negative, and it's never 0. So if we try and solve this, which we are going to do, we're going to run into a problem. So we've got 3 lots of x minus 2 squared plus 2. Now if we set this equal to 0 and try and solve it pretty quickly, we're going to run into a problem. Let's subtract 2. And we got 3 lots of x minus 2 squared equals minus 2. If we divide by 3, x minus 2 squared is equal to minus 2 over 3. No problems yet. If we square root x minus 2 is equal to positive or negative square root of minus 2 thirds, There's our problem. We cannot square root a negative number yet until we meet imaginary numbers. But we can't do it, yeah? I don't think you're going to see that until next year, or if you do further maths. So, this guy has no real solutions. So we can't actually solve this quadratic, which we're going to see more examples of when we come to something called the discriminant of a quadratic. Okay guys, that's it for this video. Turned out to be a lot longer than I meant for it to be. I think next, I'm not going to do it in order of the book. I think next we're going to have a look at sketching quadratics, a very useful skill. Take care guys.